Birdsong floats above a lively playground. Children's laughter, distant traffic, and voices fill the air woven into the tapestry of everyday life. For millions living with hearing loss, these sounds slip away, replaced by quiet and longing. In a cozy cafe, a person listens carefully, straining to follow conversation. Words blur and connection feels distant. Let's look inside the ear. Sound travels through the canal, vibrates the eardrum, and moves tiny bones in the middle ear. Deep in the cochlea, shown in our clean diagram, rows of hair cells bend with each vibration. Healthy hair cells send crisp signals to the brain. But when noise, illness, or time damage these cells, they fall silent and sound grows thin. Current treatments, like hearing aids, amplify sound to help damaged ears pick up speech and music. Cochlear implants use gentle electrical signals to bypass dead hair cells, sending information directly to the auditory nerve. These tools can help many people reconnect with the world of sound. Researchers are working to regrow inner ear hair cells. In 2013, scientists at Harvard restored hearing in deaf mice using gene therapy. Stem cell therapy aims to grow hair cell-like structures and place them in damaged cochlea. Gene therapy delivers new instructions, hoping to reprogram cells and spark regeneration. Most successes are in animal models. Early human trials focus on safety, delivery, and lasting results. Challenges remain, including precise targeting and ensuring new cells work as intended. A patient with hearing loss shares, "Science gives me hope. Every breakthrough feels like a new possibility. Progress is steady, guided by care and optimism. Each experiment opens new doors. The dream of restoring natural hearing grows brighter with every step, promising a future filled with familiar sounds." Music rises gently, a note of hope.